Okay, so we have three equations for the quadratic form. Y equal to A times x plus p squared plus q. So we discussed this. Okay? Then number two, we have what is called the standard form. Y equal to ax squared plus bx plus c. We discussed that yesterday. Then we have got a third one, which is the x-intercept form. Y equal to a times x minus x1 times x minus x2. Okay? So make sure you're aware of all three. But for this exercise, I'm going to determine the equation. I'll start with number one. The equation of that graph. Alright? Just be part of the lesson. That's the reason why you came here. Okay? Right. So here, we are given the x-intercept. We are also given the y-intercept. Right? Now, for us to find the equation here, we can't use number one because we don't know the values of what? Of P and Q. Okay? We don't know the values of P and Q. So we can't find the equation using the first one. We can't use the turning point form. We only use the turning point form if the coordinates of the turning point are provided. But here they are not. Right? Then number two, we know the y-intercept. Okay? It's 6, but we don't know the values of A and B. So that will make things more complicated. Then for number 3 now, we know the x-intercepts x1 and x2, we know. We also know, and if you look at it here, we are given this point where we've got a y-intercept. So x is 0 here. X is 0 here. And y is 6. Therefore, I can substitute y equal to 6 here, x equal to 0 here, x equal to 0 there. So I can put 0 here, 0 there, put 6 here. Right? Then I'll put x1. My x1 I can put minus 3 or vice versa. My x2 I can put minus 1 or vice versa. So which means I'm going to use number 3 to find the equation. Okay? I'm going to use the x-intercept form to find the equation. So, first thing, I'll write y. So I'm doing number 1. Y equal to a times x minus x1 times x minus x2. Always you have to calculate a first. You have to calculate that a. That a has to be calculated. You can't find the value of a by inspection. You have to do a calculation. Okay? I'm sure you can see that the graph has got a minimum turning point, so this value of a must be positive because the graph is happy. Okay? So I'll substitute y equal to 6 because at this point here, y is 6. Right? Then where there is a, I'll put a because I want to calculate a. Where there is x here, I'll put the x value at that point because this 6 here, it corresponds to 0 there. X is 0 there. Right? So I'm going to substitute 0 here. Once I put 0 there, I also have to put 0 here. It's the same value that you substitute twice. Right? My x1, now generally for me, I always identify the smallest of the two x-intercepts as my x1. There is no special rule. It's how I do it. It's your choice. You can put x1 here as minus 3 as how I'm going to do it, or you can put x1 here as negative 1, put x2 as negative 3. You still get the same answer in the end. Okay? So I'll put minus 3 here as my x1. Where there is x here, I'll put 0 again. If you make a mistake of substituting a value here which is different from here, you get an incorrect answer. So my x2 is minus 1. Right? Then I need to simplify this. Okay? To simplify, it's not complicated. So I still have my 6 on the left. Then this a here, open bracket, 0 minus minus 3, that will give me a 3. 0 minus minus 1, that will give me positive 1. So you get 6 equal to 3a, therefore a is going to be 2. Remember, the a must be positive because the graph is happy. The graph is happy, so a must be positive. I'm not done. I need to find my equation. I now need to substitute that a value of a here. Put x1, put x2. Then I'll simplify until I come to the standard form. Remember, to move from the standard form to the turning point form, you have to complete the square, as I showed you yesterday. Right? But I'm going to write my equation in standard form. Okay? So on the next page, right, I'll write y is equal to, my a is 2, my x, I'll put x. Since I'm not putting a y value for there, I don't have to put an x value. But my first x-intercept is negative 3. My second x-intercept is negative 1. Then I need to simplify this. So we get y equal to 2 times x plus 3 times x plus 1. You did this in grade 10. Okay? It's part of its grade 10 as well, what I'm doing now. So this will be y equal to 2 times x squared, x times x, that's x squared, x times 1, that will give me x, 3 times x, that will give me 3x, 3 times 1, that will give me 3. So we end up getting y equal to 2 times x squared plus 4x plus 3. Okay, now everything I'm doing here is just basic algebra, grade 9 work. So this will become y equal to 2x squared plus 8x plus 6. This is my standard form. That's the equation. I'm sure you can see that my y-intercept is appearing here. This y-intercept, this one here, it must appear in your equation as proof that you did your working out correctly. There is a connection. So you must use common sense when you are answering the question. Yes, this is the equation of the parabola in standard form. Are you following? Yeah.
So, would they ever ask you to find the equation of the parabola and then they say give this in turning point form?
Yes. 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 They will always give you, they might ask you to determine the equation in the turning point form. So if that happens now, you have to complete the square. Okay. So let's complete the square. Yes. It's a good question because sometimes it can be specified in what form you're supposed to give your answer in. Either in standard form like this or in turning point form. So from here, you need to complete the square. So if you want to complete the square, the first thing, we need to make the coefficient of x squared equal to 1. Yes?
So right now you're just changing the form.
I'm changing this standard form to turning point form. It's a very important skill. You need to know how to do it vice versa. Okay? Yes. That's the only way. You cannot do it another way. Alright? So, but I would say is probably, there's another way that you don't want to go with. Right? But there's another way besides completing this way. But maybe I will show you, if I don't show you today, maybe I'll show you another day. You can just remind me. Right? But let me complete this way. But there's another way. Alright. Now, check this out. We need to make the coefficient of x squared a 1. So we factorize 2. Okay? Remember I did factorization. So if I factor out 2, I'll get 2 times x squared plus 4x plus 3. If I factorize, I'll get that. Right? Okay. So once you factorize and make the coefficient of x squared equal to 1, then the next thing is to find half of the coefficient of x. So what is half of 4? 2. So we'll do what we did yesterday. So let me use a circular bracket. So this becomes x squared plus 4x plus half of the coefficient of x, which is a 2. I'll square that. I'll subtract it.
So to complete the square, the coefficient of x squared is more.
Always, yes. Right? Are you following what I just did here? Huh? I told you yesterday about it. Right? So I found half of the coefficient of x, which is the 2. So I added the square of that 2 and subtracted the square of that 2. Right? The objective is to create a fx squared trinomial. That's the objective. Then I'll add my 3 there. Right? Then the objective is to create a perfect square triangle, so this becomes 2 times x squared plus 4x plus 4 minus 4 plus 3. Now, your perfect square trinomial is going to be this one. Your perfect square trinomial always it has a plus between the second and the third terms of the trinomial. But this sign here, it can be positive or negative. The second sign is always a positive. This one is always a positive. Remember, I referred to yesterday. The concept of perfect square trinomials is a grade 9 and 10 concept. Okay?
What is the say 5x? What would you do?
5x where? Here. Then you find half of 5.
Yeah, if you go to the top of the
Yes.
one, yes, let's say 5x there. And
5x. Then you find half of 5, which is 2.5. Yes. Yes. 2.5, which you can write as is 5 over 2. So it means where I put 2 and you put 5 over 2, you square that. Minus 5 over 2, you square it. Alright? Are you following? Then now I can factorize. So this becomes 1 equal to 2. I will introduce a square bracket. So that will be x plus 2. Now check this. You don't have to think about what is the second term of the binomial. This 2 here, it is related to half of this. Always. So if you get half of that coefficient, that half is going to be part of your binomial factor. Always. Okay? So there's a relationship. See that half of this is going to be 2, which is this 2 here that I put there. Are you following that? Then you square this. Then minus 4 plus 3, that will give me minus 4. Right? I'm not done. I need to remove the square bracket. So if I remove the square bracket, you get 2 times x plus 2 squared minus 2. So this is now the turning point form. You know what? Right? I also need to show you another way of finding the x value at the turning point using the x-intercept. Okay? That's also, you can also find the x value at the turning point using the x-intercept. Okay? But can I do it now?
No, sir.
Yes.
No, I have to do it now before I move on to interpretation. Right? Please, what we can do, can you add this? Let's go there. It's unfortunate that some people are not here. Right? Some people are not here. That's very unfortunate. Alright. So, you remember where I found the x here? I found the x value at the turning point. Right? There is a method 3, and then I use method 2. Right? So let's put method 3.
So you like to teach with less students?
No?
You like to teach with a little bit less students?
No.
Because you seem to be teaching very well today. Some days you
Don't make me laugh.
some days you know what I'm saying? So,
Don't make me laugh. Alright. Okay. Let's carry on. So, method 3 You can also use the x-intercept. You can also use the what? X-intercept. So the x value at the turning point, please add this somewhere, is going to be equal to x1 plus x2 all over 2. It's like the x value at the turning point is the midpoint value, is at the midpoint of the two x-intercepts. So that is method 3. And it works. Okay? It works. You can test it with the other questions that we did, but you have to know the two x-intercepts. If you don't know the two x-intercepts, then you can't use it. So this formula it only works when you know the two x-intercepts. Okay? Are you following that? Right, so I'm gonna try and use that if possible. I have the time. Right, so I am here. Okay, standard form. This is your standard form. X-intercept. Sorry, the turning point form. Okay? Can I show you something?
Yes.
Just for your interest sake. I said the x value at the turning point is equal to x1 plus x2. I want to verify, I want to show you that we can use this formula to prove that x at the turning point here is negative 2. Okay? It's negative 2. The x value at the turning point is negative 2. It's not a positive 2. So if you look at the first x-intercept, it's minus 3. The second one is what? Minus 1. Now, if I substitute x1 as minus 3 and x2 as minus 1 and divide by 2, I will get minus 4 over 2, which is minus 2, which is the same as the x value at the turning point. Are you following? The x value at the turning point, you see the x-intercept here, x-intercept there. Remember, at the turning point is somewhere here. The turning point is a midpoint of the x-intercept. So which means I can find that x value at that midpoint by adding the two x-intercept values and dividing the sum by 2. Because remember, the x value at the turning point it's at the line of symmetry. Therefore, it's a midpoint. Okay? Right? So we can do that. If you want, you can use the other formula as well. You come from x equal to minus 2 as your x value at the turning point. That is, if you use x equal to minus b over 2a, you substitute b, see b is 8, so this will be minus 8 over 2 times 2. That will give you minus 8 over 4, which gives you minus 2. Do you see that? So the same answer that I got here is the same answer that must also appear on your equation in turning point form. Now, all these concepts, you have to know them before you start interpreting. Before you start interpreting, you have to know all these concepts. You can only be able to interpret a graph if you can sketch it, you know all its properties. If you don't know how to sketch it, you don't know the properties of the function, you have problems with interpretation. Okay, any question? I've covered quite a lot here. Is there anybody who has got a question? Alright, so let's move on. Let's do another one. Right? Let's do another one. Right. I can't do number 3 because it's on the turning point form. I have done that. Okay. I need one with x-intercepts. Like, say, this one here. It has a maximum turning point. So I'm going to do number 4. Okay? So, number 4, first thing, you must know your equation in standard form, right? Or in also the x-intercept form. So it's y equal to a times x minus x1 times x minus x2. I'm using this one here. In fact, I can also use even the turning point one because you see that the graph, it has got a turning point. So I know the x value here, I know the y value there. The x value here, I know it. And the y value, I know it. So this is actually a great chain function. Because the line of symmetry is the y-axis. So it's a great chain question, right? So to calculate a, I need to substitute the value for y, which is 18. Then I'll put my a, the way there is x there, I'll put the value of x there, which is 0. x1, I'll put minus 3. x2, I'll put 3. Where there is x there, I'll put 0 as well. Alright? Are you following that? Then I need to simplify this. Now, I'm sure you can see that the graph has got a sad face. So is the value of a supposed to be positive or negative? Negative. So we end up having y equal to a times positive 3 times negative 3. So, okay, sorry, I'm supposed to put 18 here. So this is 18. So that becomes 18 equal to minus 9a. So a is negative 2. Right? Then the next thing, substitute that a, so that I'll get y equal to minus 2 times x minus 3 times x minus 3. This will give me y equal to minus 2. That will be x plus 3 times x minus 3. Then we use FOIL. If I use FOIL, you get y equal to minus 2. This is like a difference of 2 squared, so I'll get x squared minus 9. And my final equation will be minus 2x squared plus 18. So that's my final equation. Okay, so that's my equation in standard form. Now, this standard form here is a grade 10 standard form. Okay, that's a grade 10 equation. Right? Any question? Any question?